Hi there, my name is Maxim and I'm a software engineer with more than 8 years of production experience. Today I start a new course, it's a Git for beginners. So in this course I will show you why do we need Git and why you have to use it, because it doesn't matter are you front-end engineer or back-end engineer, or you are just beginner or are you experienced developer, you have to know Git. And you have to know version control system, any of them. So in this course I will start from the simple. It will be how to install Git, push some changes, pull changes from the remote server, how can we resolve conflicts or reset the latest changes. In the end I will show you how to work with remote repositories and how can we choose the optimal branching strategy. I will show how do we use Git on our everyday work and how can you use it. So good luck and let's start. In this video we will talk about concept of version control system and take a look how we can organize it, or take a look on options how can be organized such a system, how can it be built. Let's imagine that we have a file with our markup for HTML and we have a title. We have title with such some value, and after that some manager came to us and said that we should update it, and we have another version with a new version of this title. After that, in a couple of hours, somebody else came to us and thought that it should be changed again and it should be built dynamically, so we updated it again. And after that somebody came again, or requirements were changed, and we have a new version with the first one version when title should be set dynamically hard-coded. So as a result we can see that we will have a lot of copies of the same file, and if you, in case you have a lot of files, you can put it in different folders and then make copies of these folders. A lot of us developers who started to just they work in this way. They have a copy of each project, a few copies with different changes. But what's bad in this case, that you have a lot of files and you do not know how it was changed, what was changed and who changed this. And just opening information of this folder, you can find when it was changed and maybe some comment, but it's not a good idea. After that, you can try to use some cloud systems, for example, Google Drive or Dropbox, but it can't solve the issue with your coding, with your software. Because when you write your program, there are a lot of files, a lot of changes, and you need sync up this data, and the cloud platform doesn't work well for your code. Another option, it can be you can try to share your file in your local network with other developers and try to do work on these files with a few different peoples. But the issue is that code will be written by another developer. For example, if you're doing something and you have not the last version, somebody else can rewrite this file and your version will be outdated. So it's not a good approach. But what is good, it's a version control system, something like Git. So let's take a look on requirements for such system. So requirements, it should have backup and restore option. So what does it mean? It means that every code, that the code you are creating, it should be saved, and all versions should be saved, and in any case or in any moment you can go back to the previous version and you can get the data, and you can get the data, especially what you need. The second item is synchronization. It should allow to synchronize work of 1, 2, 3, 50 or 100 developers, and it allows to do one work together for all developers, and you should be aware and should know that your changes won't be deleted or removed. Somehow you can get the latest data, the latest version, check the difference and push updated version based on your changes and changes you get from the server. The third requirement is reverting changes. So in any moment you can revert everything what you did and go to the previous version and be sure that everything will work fine. Okay, the next requirement is track changes and ownership. It's a very important part. So for example, you open file and see that there is some changes and you do not know how it works, some complex algorithm or some difficult change. You can always find the ownership of these changes, who did it, and go to him and ask why it was implemented in such a way and what was changed and why it was changed. Also in this case you can check what specifically he changed and what was before what was changed. It's a very important part. The next one is sandboxing. Sandboxing is a place where you can put some your experiments. For example, you want to try some interesting new feature and you do not want to show it for your customer, or you don't want to publish into production. So you need to have a place where you can put your code. You want to save it, and then if everything is okay, you can fix it or finish this work and then push to production. But version control system should allow you to have such a place, such possibility. And the last one is branching strategy. So you can create different versions of your code in different branches and work on branch you need. And in the end you can merge everything together and have the final version of your code. So version control systems, they were created many years ago, I guess when we just started programming, and we can talk about them in two options, how they are working with your files. There are two popular strategies of organizing version control system. It's lock, modify, unlock strategy and copy, modify, merge strategy, and something between, something combined of these strategies. It's Sven works in this way. So in the next video we will talk about these strategies and I will show how it works. I mentioned two strategies we can use. It's lock, modify, unlock and copy, modify, merge. So let's take a look on this and we'll find out how it works. So we will start from lock, modify, unlock strategy. So let's imagine that we have two developers, it's one Maxim and another one is Oksana, and they are creating some program. In our case they will write song. Right now it's empty, and how they can work. So for example, Maxim is starting work, and what he's going to do, he blocks this file, so nobody else can change this file, they can just read. So Oksana can read the data, but she can't change it and can't update this file. So this developer, it blocks the file, and then he created the first version of the file. So he created 3 lines of code, and after that he wants to move these changes to the server, and in our case it's the song text. When he moves it, this operation it calls commit. So he committed his changes to the version on the server, it's our song text, and after that he can remove blocking and other people can update or change the version. So in our case, Oksana developer, she can get data right now, or she even can get some notifications that this file was updated and unblocked, and right now she can start work on this file. So what she has to do? The first one, she should update her local copy. This operation is called update or pull. So she has to pull the latest version of the code, and then check, compare it with her own and update if it's possible. So she updates the local copy, gets data from the server, and after that she blocks the file and updating her local version, adding 2 new lines. And right now nobody else can work with this server copy because it's blocked. It's locked by Oksana, and just this developer can update it. So she updated this version, and she has to commit the latest changes to this server file song.txt, and she makes commit, and after that updated version is on the server. And when she pushed these changes, committed, she can unlock this file, and everybody else or any other developer can read this data and modify it, because previously they could just read data without updating or modifying these changes. Another strategy is copy, modify, merge. It's a bit more complex, but it's mostly used right now. So how it works? Let's check. We have the same program, it's our song, and we have two developers. So they're developing their own versions of the song or some parts of the song. And for example, that Maxim, he first finished his work and decided to commit changes. So he makes a push to the server, and the server compares the first versions of the file. In the beginning, the version of song, let's call it version 0, it was empty file, and his file was empty too. It compares that versions were the same and tries to push changes. Server accepts these changes, and now we have the latest version of the song on the server. After that, Oksana tries to push her changes to the server, but what we have? She started from the empty file, and server was already not empty. It was with previous changes from Maxim, and when she tries to push her changes to server, there is a conflict, because here she started from version 0, but on the server was version 1. It was version which Maxim did, and we have a conflict. In this case, we need to resolve conflict. We will talk about conflict resolving later, but right now we have such situation. So how can we handle this situation? It will look like this one option. So previously what we had before, what Oksana had before, it was empty file. It was here, empty file. Then version from the server, and what she has on her own version. After that, when she will resolve conflicts, after that she have to resolve conflicts and push updated version to the server. In this strategy, nobody can block any file, so any one developer can work with this file and update it, but in case they will have some conflicts, they should resolve these conflicts and then push the latest version. For example, she can update in cases if these two developers implemented the same functionality or the same implementation. Oksana, when she tries to resolve conflict, she can remove her own changes or Maxim's changes and leave the last one version which works, or just take some part of his implementation and take part from her own implementation and then push the latest version to the server. Also, when we talk about version control system, we can talk how they handles history and work with file. So in this case, we have two options: it's centralized and distributed version control systems. So let's take a look on centralized version control system. So in our case, we have a server with a repository which saves the whole history of our changes, who did change, when it was changed, and some comments what was changed. And we have different workstations. It's computers of our developers. In our case, we have 3 different developers with 3 different computers, and on these computers we have working copy. It's just a file copy. We do not know who did these changes or any changes, what was changed and when. And when we want to update the version, we just commit to the server. Server saves the history, who changed and what was changed. And if we need to get the latest data, we update from the server. It's pretty simple, but what is disadvantage of this approach that the whole history is saved on one server, and we need to create some backups to save this server, because in emergency case or if something will happen with server, everything can be lost. And another version is distributed version control system. It has the same server with the whole history, but in the same time we have developers, and each developer on his workstation, it has a copy of repository. So in our case, if I'm developer number 1, I have my working copy and I have repository of the whole application, and when I do something, I need to commit my changes to this my local repository, and after that I can synchronize it with server repository. Yes, there may be some conflicts, I will resolve conflicts, but after that all my changes they will be pushed to the server. What's the benefit of this approach? That each developer, it has his own copy of the repository, and he or she knows what was changed, when was changed, and by who. And after that, when we implemented some changes, we can synchronize this, our local version, with the server version of repository. And sometimes if something will happen with this server, we can get the data and the last version from any of computer we have in our network. We can call it this way, and everything will work fine. We will talk why we decided to use Git as our main version control system and why is it so popular. Git was created approximately 15 years ago in 2005 by Linus Torvald team. Linus Torvald is the man who created the Linux kernel. It was created to replace the previous version of version control system. It was BitKeeper, and now it's very popular and world-known version control system. So what is Git? Git usually is a very simple system based on a command line interface, and why it's so popular. So here we can see the logos of companies which are using this system, and very popular in these great and famous companies. So also it's open source, absolutely open source system which is distributed under the GNU license, and you can use it. Also, if we take a look on the Stack Overflow survey, it's 2018, we can see that almost 90% of developers they are using Git. It's a really big number. Previously was a Subversion, but now it's not so popular. So let's take a look why Git is so good. For example, if we open benchmarks and comparing it with Svan, we can see that it's faster. In some cases it's faster in 50 times, for example for log command, and comparing for commit and for diff, for log, it works much faster. And here we can see the difference in seconds. Also, how Git works. There is a function which generates a secure hash algorithm. It's a token, and Git takes your file, and even if one bit is different, it will generate a new version of this file. So it's very secure, and it's almost impossible to lose some piece of your data. That's why it's very popular and very secure. Also, it's very easy to work with branches in your Git repository. It's almost free based on space and time, so you easily can create different number of branches and work with them as you want. I will show you how to install Git on your computer. In this case, I will install it on my Mac OS, and I will show you how to install it on Linux. Installation for Windows is the same as we install for macOS. So let's go to the main Git site. It's git scm.com, and on the main page we will see the button for download Git. So let's click it, and after that we will download it. It will be redirected to some SourceForge site, and after that you can download. Here you can download the latest version of Git. Okay, let's open it and install this package. It's okay. So let's install it with OpenWiz installer, and open. And now what we need is, let's click continue, and everything will be on default. My name. Okay, so everything was successful. Let's close it, move to trash. Okay, and now we can open our terminal and check version. So we see that it's the latest version 2.23. So let's install it on Linux. So for this we will use Google Cloud Platform. Here I created a Git instance. It's a virtual machine instance, compute engine. So let's connect. It's just the smallest F1 micro server with allowed firewalls rules for HTTP and HTTPS traffic. So let's open it. Okay, we are here. It's Debian. What do we have? Yes, Debian latest version. So first of all, let's update it. And after that, install Git. Just apt-get install Git. Yes. Let's clear it and check version. So Git version. It's the same, not the latest, but it's okay. So let's. What's important in Git installation is that you do not need any dependencies for Git. You don't need to install Java, JDK, or any global variables. You just install Git and everything works from the box. The next one what I want to show is smallest configuration. Let's generate small SSH key, which we are going to use on our repository servers. In our case it will be GitHub. So again, let's go to our console in our computer. Let's clear it and generate the SSH key. For this one, for generator, we will use SSH keygen. It's installed on Mac, on Linux, and if you are using Windows, it will be installed with Git at the same time. As a type, I said RSA, and as a comment, it will be my email, my old email. Yes, so it's C should be uppercase. Here we can see the path we are going to save our file. Git will look it for this folder. I just gonna change a bit the name because I have already this file. So let's copy and set git basic. Here we need it's a password, passphrase. I can leave it empty, but you can add something simple because it's you're going to use it when you're going to log into the system. I will put it the same. It's empty, and here we have this file. So let's go to this folder and check what do we have. So let's go to SSH. Here we have this file. So here we have a public key, is a GitHub basic public, and we have a private key. Let's check what's inside. So here we can see that private key. Never do not share this file with anybody. It should be on your computer, but you can share a public key. Let's take a look on public key. It's our public key, and in the end we have our comment, it's our email. So right now what we need to add this public key to our GitHub repository. Okay, I'm on GitHub repository. You can go to settings page. It's settings, and here we see that we have SSH and other keys, and let's add the new SSH key. Title will be Git basic. And here we need to put our SSH key. Let's copy the whole string with comment. and save. So here we can see that we have our first key, and then we can use it. This key it will use for subscription all commits. We're going to push to this GitHub server. The next one, what we need to configure, it's configure username and email on Git. So let's go again to our console. Let's close it and let's go to home. So we need to put username and email to identify user who pushed some comments. So how can we do it? We can set comments like git config with flag global. It will be for all repositories in your computer. If you want to use for your local repository or just for one repository, you can configure it in another way. It's not global, it will be local. And set user name. We can set, and also to do the same for email. It's my old email again. And now we can check what we set by calling the same without parameters. So let's check our email. Yes, it's what we expect, and our name. And name is the same. So now we finish configuring Git on our local machine. In the same time, we can do the same configuration on our Linux server. So here in Linux, we can check global configuration, and now it's empty. So you can configure it by yourself. We are going to use this server to show how Git works from different computers. You can use any server. It might be your local computer, it might be Google Cloud Platform server or AWC. Doesn't matter. Just create anything what you want. I will show how to create a remote GitHub repository and how we can connect it, fetch data or push data to this repository. So what we need to start. Let's go to github.com main page repository, sign in or sign up, and on the main page we have button new. Let's click it, and here we can create our first repository. I will add name git demo, so we can do it. I will git basic. So yes, it's a unique repository, so we will create it public. Also we can create it private, and nobody else can use it if you do not provide access to this repository, but private is okay. And also I would check this checkbox, initialize this repo with readme. It means it will create first commit with readme file, and it's done just for simplify this demo, because the first commit will be added, and then I will show how to pull this data from the server. So let's check it and create repository. So here we have our Git basic repository is created. We have one commit, we have readme file with this line, and right now we need to clone this repository to our local machine. So let's go to clone and download, and here we can use SSH because we already created SSH key. Let's copy it, and let's go to our console and go to the folder where we are going to put this repository. So on our computer, let's copy paste this command. It's just URL, but it doesn't work. What we need the command git clone and this line. Let's click it. So cloning. So right now we have a problem with connection to our GitHub repository because of when we generate SSH key, we set another name, not the ID RSA, what is default. So to solve this problem, we need just add this key to our key store. Let's call command SSH add and add this Git basic name. We already generated it before. So let's call it. It mentions that it's added, and now let's go to our folder. But first of all, let's check if it works. Let's call command sshvt github.com And here we will see that hi, you are successfully authenticated, so everything works great. So now we can go to the folder where we are going to save our repository, local repository. So let's clear it and okay, and let's go to our Git basic repository, and again let's clone, copy SSH and call git clone. Now we see that everything is okay. Let's check our folder. We have Git basic. Let's go to Git basic, check. So here we have readme. We can open it. Git basic, and it's okay, it works fine. Let's check, is it our repository? Let's call command git remote with the variables flag, and here we can see that we have origin, it's GitHub. So everything works fine. Right now we can check status of our state of our GitHub repository. We see that we are on master branch, and it's okay. So right now we can add some file and check what's going on. Let's touch txt. Let's check status again. So right now we see that we have some new file untracked, and we do not know what to do with this file, and Git recommends add this file. But first of all, let's add some text here. Let's add our first line of our song. Let's save it. And right now we can add this file. So let's call git add and file name. Check again status. So now we see that it's a new file, song.txt, and Git recommends to restore stage to remove all changes, but we don't need to do it. We want to commit this file and push it to server. So let's commit our changes. So let's call git commit with comment edit song.txt. Let's commit it. So again, status. We see that there is nothing. Everything is committed, but if we will open our Git repository, we will see that nothing happens here. It's because we need to push our changes to remote server. We need to synchronize our repositories, local and remote. Right now let's check our log, git log. We will see that right now we have two commits. The first one, it was created when we created repository and added readme. This initial commit. It was created by another email, and we added song.txt. Right now we need to push our changes, so let's call git push. And here everything is pushed. Let's check what's going on the server. And here we see that we have one file. Okay, so it works. We can see it's what we expected. So right now I will show you one more option how we can clone a repository. Previously we used SSH, and it's because we created SSH key on our computer, but we have also Linux server without SSH key. We didn't add it yet, so we can use HTTPS option. As we created a public GitHub repository, we don't need to authorize or do something like it, so we can just copy SSH path and go to our server and clone repository in our server. Let's check where we are. It's empty home folder. Let's git clone. So we see that it's done, it was successfully cloned. We do not need to add password, login, or even SSH key. Let's check what we have. We have Git basic. Let's go to this folder. And we can see that we have all the same files. We can clone repository without generating SSH key, but in our case it's a public repository and it works fine with public repository. I will show you how to pull data from the server. So let's imagine that somebody else from your team did some implementation, some changes pushed to the server, and now you need to get this data for your local repository and synchronize your changes with his. So right now for demo we will open our song.txt, and here in GitHub we can edit this file. So let's go to edit and add another line of our song. So let's add one new line, and here we need left comment commit changes. It's what we changed, and use email. Right now it's this one, and now we can commit our changes. Commit it, and when we go to the basic main page, we see that here we have 3 commits. Let's go to our repository, local repository, and check git log. And here we can see that we have just 2 commits, and it's okay because we didn't synchronize our repositories. So we have 3 commits on remote repository on GitHub and just 2 commits here locally. So in GitHub there is a command which calls git fetch, which will synchronize your repositories, but it will synchronize just branches and tags, and it will not change the content of your files. To do it, there is a command git merge, but we can simplify our work and combine these 2 commands with one command. It calls git pull. So let's call git pull, and we will pull data from a remote repository. Let's call it. And here we can see that was changed one file, song.txt, and something was added. So we can open this file and see what was added there. And now we can see that we have one more line added to this file. And if we check git log, we see that we have this comment in this commit that added new line, and it was added by Maxim. So we have all synchronized files in our local repository. I will show you how we can use the graphical user interface with Git. So previously in all our videos we used the command line tool, and it's not the best solution when you are working with a huge project where there are a lot of files and a lot of changes. It's okay when you have one file, you need to change something, add something, or update some small file or some small piece of information. For larger projects we need to use graphical user interface, or some of us have to use it because it simplifies our work, and especially for beginners, graphical user interface is a good solution. So today I will show you how can we use graphical user interface from the box, what is coming with Git. So let's start with, so as I mentioned, the graphical user interface will simplify our work. So in Git there is a Git GUI, and I will start with ampersand it. It will start on a new process, and we can work in our console and in the same time in this graphical interface. So let's start it. So here we are. It's our graphical user interface. It looks pretty simple without anything features, and it's okay right now. So what we can see here? Here right now we do not see almost anything. So let's do some small changes. Let's edit our song.txt file. So let's go and add some new file, new line. We will save it, and right now let's check in our GUI. Let's click rescan button, and now what can we see? We see that we have this file. It was modified, song.txt. We see that in green color something was added, so new line was added, and we even can check if something was deleted. Let's do it again, and let's delete something. Open Git GUI, again rescan, and now we can see that red it was what deleted, and green what was added. So right now it's on state changes, and we can commit these changes to our Git repository. So let's do it. To do it, we need to click on this icon, not text, not the file name, it doesn't work. I'll click icon, we click it, and now we see that these changes are staged. And right now we can add some commit, and after that we can commit. And of course we need to push to our server. So here we can see that it's master remote, and let's push. So as we already configured SSH key, it should work fine, and yes, success. And let's check it on our GitHub repository. So here we are in GitHub repository, we see that we have 4 commits. Let's open, and now we see this added new line. So everything was changed and was pushed. It works as we expected. Also, what can we do? What's going on if we, for example, we will change 2 files? So let's edit this one again. Let's remove this, and we update readme. So again, let's open GUI, let's rescan, and now we see that we have 2 changes. It's in readme file, again something was deleted, something was added, and in txt. In some txt. So we can push, for example, just 1 file or 2 files, just edit or click again and remove. So we can push, let's push them together, commit, and after that push to the server. In case if you're using SSH key with a passphrase, in this here you will need to enter your passphrase, your password. And let's push it. So it was pushed, so everything works fine. Another tool I will show you, it's Git-K. Git-K, it's a similar tool. It's coming from the box with Git. It looks like Git-K. So all these commands we start from the Git repository. Let's start it. And here, what can we see? This tool shows a history of our changes. We can see that here we have all commits we had, its initial commit, added sync, and added new line, the last 2 commits we did right now, new updates. So here we can see that old version, new version, difference, and it shows what was changed. And this tool is coming from the box. But what I want to mention that usually we do not use these tools because they look like this is Sparta. Here is nothing almost. So there are a few better tools. So let's open Git GUI's clients, and here there is, for example, Source Tree. Source Tree is I guess most popular I know tool, because I heard a lot of people using it. So you can open it, and here you will see everything is the same, but it works much better, looks better, at least for me and other developers. And you can see the history of your changes, all files, what was changed, and everything what you need to work with your Git repository. So you can take a look on this application, or you can choose something else. There are a lot of interesting tools. Another one what I can recommend you, it's using integrated Git in your IDE. For example, I'm using WebStorm. It's a lot of years I'm using it, and Git is integrated here, and version control, and I can use it in the same way. I see the all commits, I see what was changed, I can check the difference, or in our case it was added. Let's check. Here I can see what was changed, what was before, what was after, difference. I can see commit, and also here we can see we have local changes, what was changed, we have log. Also we can do all operations, we see who did these operations, we can filter We can choose a branch, so everything is integrated here. Usually it's much better and it's easier to work, because here you can see all your changes, your file, what you did, and then you can check the previous history, and I recommend to take a look on this approach too. Thank you for watching, that's it. We will take a look inside the Git folder, and we'll find out how Git works from inside. So in the Git, everything is built based on the graphs, and there are three main parts. It's commit, tree, and blob. And right now we'll check how they work and how can we get information from this data. So let's go to our repository. So let's go to .git folder. We will check what is inside our repository. Is just two files, but Git it's a hidden folder because it starts from dot. So we can just cd git, and right now we see that we are in the Git folder. Let's check what we have inside. So in our case we have a couple of folders. It's hooks, for example, logs, refs, and a few files like head and index. Okay, let's go to head and check what we have inside. So head is not a directory, so we can get head. So in head it's a file, we have a link, it's a reference to refs heads master. So we can go inside refs, cd refs, and here we have three folders. It's heads, remotes, and tags. So in our case we can go to heads master. Let's go to heads, and here we have one master file. In this master file we can see that there is SHA-1 function token, and let's take a look what does it mean. Let's open new tab. Again, we are in our repository. Let's call git log, and here we see this the last commit, and in our case in the head we have reference to the same last commit, because we have so we can see these numbers, they are the same. It's the last commit. Also, let's go back. Also, we have here remotes folder. Let's go to remotes, and here we have origin. Let's open it. It's a folder, and here we have two files again. So we can check head. It again is a link to origin master, and let's check master. And in master we have the same link because it's the same commit. As we already fetch data, pull data from the server, and we synchronize our local and remote repositories, we have these links for the same commit. Yes, it's the same commit. So okay, let's go to upper, and here we have also index. So in index we have some binary information. What is saved in index? When we add some file to Git with command git add, Git saves this data in this temporary index folder, and when we will commit it, it will add to Git storage in objects, for example. So we don't need it. And what is the most interesting for us right now? It's objects folder. Let's go to objects, and here we see that there are a lot of folders, and let's find out how it works. But first of all we need a bit of theory. So Git works with a commit, tree, and files. So we have a commit which refers to a tree, and the tree can refer to file name. It's for song.txt, and the blob. Blob it's a binary large object, and in this blob we save all data from this file. And for example, if we have a few different commits, we have the same file with the same changes, we can refer to the same blob and do not duplicate it and not create a copy. Let's take a look, for example, on this commit. We will get inside our first commit and we'll find out what's inside. So we have this commit, and let's call git show with flag s and pretty row, and we need to enter this commit token, but we don't need to copy the whole string. We can just start typing, for example, 5 letters, it will be fine. And so here we can see, we can get a bit more information. So we see that it's commit, this commit, we can see the tree, what was saved in which tree refers. We see the parent, author, and committer. And also we see this comment we added. So let's go inside this tree and take a look what's there. So we can call git ls tree, and the same, we need to enter first 5 letters. It's 47. And here, as you can see, we have a blob which refers to these 2 files. It's readme and song.txt and this ID. To get the content of this blob, we can call command git show, and we can add again 5 first letters of this token. It will be, and inside this blob we can find the content of our file. This is file name, and inside this blob we can see this content. So where it's saved in the Git. Okay, let's take a look on our objects. Again, we are in our objects folder, and what do we have here? We have this blob, and the first two symbols in the commit token, it's the name of a folder. So Git tries to save space in file system, and first 2 letters it's a folder name, and other letters it's a file name. So let's take a look what we have with 70. Here is this folder. Let's go to 70, and what's inside? And inside we have one file. It's this CEE. Yes, it's what we needed. And let's open it. And here we see that here's some binary information. We cannot read it, but for this purpose we have a git show function, git show command, which will show what's inside. And inside is this binary file. And it's what we can find on Git folder. What's interesting is that usually we don't work with these Git folders and the Git objects. You do not need it. Everything is handled by Git, but in case if you will break something with these folders, for example rename it or delete it, it's very difficult to fix the problem, and usually you need just delete this repository and clone from remote server, clone remote repository, and start everything again. It will be the simplest solution. I will show you how can we undo some changes or revert changes we did before. So how can we do it? To understand how we can revert changes, we need to find out where we are, and based on this information we can do different steps. For example, we can implement changes on the file system level, or we already added these changes to staging and ready to commit, or we even committed file, and based on this information we need different steps. We need to do different steps to revert our changes. So let's start from the first version. It's file system changes. So we just add some file or changed already created file, and we didn't commit this file, didn't add it to staging area, just want to remove these changes. Yes, we can just copy the previous version and then delete it manually, but what we are going to do in case if we have a few files, it's very difficult to handle a lot of files. For working with file system, we have a command git checkout with file name. We can pass a file name. Let's try it. So let's open our repository, and here we have two files. Let's edit both of them and check what the Git will show us. So we added this one, Ctrl X, we save, and edit readme also. Ctrl X, yes, save. So now let's check what do we have. It's Git status. Right now we see that we have two modified files, it's readme and sound, and Git suggests two commands. Use git add file to update what we will be committed, it's add to staging, or we can git restore and the file name to discard changes. In this case, this command will remove these changes, but let's try delete it with git checkout. There is a command git checkout, we checked already. Okay, let's try git checkout and file name ---- and song.txt, for example. Let's call it, and again let's call git status. So now we can see that we have just one file modified, it's readme, and let's take a look on song.txt file, what is there. And here we see that we don't have previous line. We don't have previous changes, so everything was deleted, and it means if you undo some changes, remove them, you cannot go back. So in Git, everything what you already deleted is deleted. It's okay. And right now let's try to revert all changes in all files. For example, let's edit again this file, save it, again git status. We have two modified files, and let's revert all files. For example, we have a couple folders. In each folder you have a lot of files, and we want to revert everything. So in this case we can call git checkout dot means all files and all directory in this directory below, so everything will be restored. So we see that updated to path, and git status shows that there are no any changes. And we can check readme, and we see that there is no change. Let's go back. Okay, it works fine with the files we created before and modified, but let's imagine we created a couple of new files. Let's clear it. Let's touch, for example, report docx, and touch and some Excel. And right now we call git status. We see that we have two new files, and Git suggests just to add these files because there were no such files before, and there were no previous version. So if right now we will try to git checkout report, for example, we can see that this file doesn't have the previous version, and we can't revert because here we can see that it didn't match any files known to Git. So Git doesn't know about this file. So how can we remove it? For this we have git clean command with a couple of flags. There are three of them we are going to use today. It's X. It means ignore rules from gitignore file. We'll talk about it later. D, it's directory. It means folders, remove folders and everything what's inside. And F, it's force. We need to call this command to apply these changes. Okay, so let's call it git clean, for example, without F, and we see that it requires force. We can change this configuration, but we are not going to do. We just call it with F, and here we see that two files were removed. And if we call git status, we see that everything is fine, no files, and tree is clean. And the next one, what we are going to do, it's for example, we already added to staging, so we are ready to commit this file. Let's edit again, Let's save it, git status. So we have this modified file, and we need to add to it to staging. Let's call, for example, git GUI to try do it in this. Okay, let's try to do it here. Let's rescan, and we see that we have this one file, and let's add it to stage. So here we can close it and git status. So we see that this file is modified. So let's try to check out this file. So let's call git checkout and song.txt and git status. So we see that nothing was changed, it's still modified. So to revert the change, we need to remove it from index, from staging area to file system, and then we can delete it in file system. So to do it, we can call command git reset, 2 flags and 2 minuses, and again song.txt. So we see that unstaged changes and git status. We again have one just modified file, it's called red, and now we can call git checkout, git status, and we see that everything is clean and we have no changes. And if we will open this file again, we see that we have no changes. Okay, let's clean it. And the third option, when we already committed this file. So here we can use git reset with head, tilde, or caret. And here number of carets, it means how many commits we need to go back. Or if this number is very big, huge, we can use a number. So for example, 2 commits behind, and everything what was committed before will be uncommitted. Or we can do another option, it's commit with amend. So what does it mean? For example, you committed some files, and this commit is more or less okay, but you need to change it. You need to update this commit. So in this case, we can do not remove it. We can just edit this commit and leave what we have. So let's try to do it. So let's check status and git log. So right now we have February 19 last commit, new update. So let's try to update this commit. So we will change one file. Again, new line, save it. And let's open Git GUI to show how it works from UI perspective. So, and here we have this one new line. We can add to stage area, and here there is already a button. We can new commit or amend last commit. Let's change it to amend last commit. And in stage area, we see that in the last commit we had 2 files. We had updated 2 files committed, and now we see that new updated. It's the last commit message. We can add something like edit new line today. So, and let's commit it. So right now we can check our git log and see that we have this new message. It's added new line today, and this commit was implemented February 19. It was yesterday. We did these changes today, but commit is from yesterday. It's what we expect. And git status, we just see that we have one different from remote server, but it's okay, everything locally is updated. But let's imagine that we committed this file and we won't revert these changes because it's not what we expected. Amend command is a great command, and for example, I use it almost every day, I guess every day, to push to merge request one commit. Just we will talk about later. But what we are going to do if we want to remove the whole merge request, the whole commit. So in this case, let's call git reset head and for example 1 caret. So on state changes, we see that git status. We see that right now we have modified 2 files. It's from last commit, and if we call git log, we will see that we do not have the previous commit we had before. And we don't have a commit we implemented yesterday. We committed this amend flag. Today we have just 2 modified files. And for example, these files are already in file system. The previous commit was removed, and we can delete this file or add to staging. So let's check rescan, and we can add a file to stage. Let's again git status, and here we see that one file is modified and another one is already added to stage. So in case we call git checkout dot, we will see that we have just 1 modified files, but we don't have readme file. And let's rescan, and we see that we have just readme file. Now you know a few ways how we can revert commits. So it's very important because in Git one of the most popular questions is how can I revert my last commit, or how can I undo or uncommit my last commit, because we did something and we won't revert it. And so right now we know how to do it. We learned how we can reset changes and undo anything what we did in our system. We committed it and saved to Git. And in this video we will go deeper to git reset command and find out how it works and how can we use it. In Git we have 3 levels of saving data. It's a file system, just added this file to the system. Then we can add this file to index or staging area. We need to call command git add, and after that we can commit this file with the command git commit. So we're moving our file changes from one level to another one. With command git reset we can move these changes back to the index and file system level. So git reset has a couple of flags. Soft is the safest flag. It moves your changes from commit to index, and it's the best way if you do not want to lose something. By default, git reset works with mixed flag, and it moves directly to file system, and your file will be untracked for Git. And there is flag hard. Git reset hard, it deletes your changes completely. So be careful with this command, because in case you will use it, it will delete your changes, your files, and you cannot restore it. Let's go to our Git and try to change something. So we are in our Git. Let's check git status. We have one modified file. Let's git add it and git commit flag and the message related to readme. So let's check git status. So right now we have nothing, and let's take a look what do we have. Let's edit our song.txt. None song.txt, and so we added one file. Let's save it, and for example check git status again. It's modified. Let's edit and commit. So now we commit, we can check git status again, it's fine. Let's clear it, and let's try to git reset soft, how it works. So we call git reset is flag soft, and say how many commits we want back. It will be head tilde 1. We will go 1 commit back, and now git status. So we see that we have this song.txt file we changed before, and it's modified. Let's check what's inside. So everything is inside. We see that a new line and a new part of this song is added. In case we will open Git GUI, let's rescan. We see that this file is already in stage changes, and we can see this new part what we added. So, and again we can commit this file. Let's commit it. And let's check git log. So we can see that we have added new line again, and it was the last commit. Also for git log, I will show you one small comment. It's git log with the flag pretty one line. In this case, we can see that we have all commits in one line. We know where's our head and the last commit. We will use it later. Okay, and flag mixed is what we have by default. So let's try to git reset mixed and had the same caret, one commit back, and we see that unstaged changes its sunk.txt. Let's check this file. It's a git status. This one is modified, and in case you will open git scan, again we see that this file with the same changes, it's unstaged, and we can get sunk.txt. We see the same file and with the same change. Also, if you need remove it, you can git checkout or everything what you need. But again, let's commit it. Commit. So git status. So as you see, we cannot commit because we didn't add it. So don't forget to git add and git status, and like right now we can commit it. It's fine. So let's clear, and right now we will test git reset hard. Git log. One line, we have this new commit, and let's call git reset hard and go one commit back. Now it shows that head is now at A704. It's this one. It's this one J1 commit token ID, and let's check again log pretty. So we have now the previous commit, git status. We have no changes, and check LSL sunk.txt. Let's check what we have inside. So we can see that just new line, and we have no our latest changes. Everything was removed, and we have just previous version. So if you need just delete your commit, you can use this command, but be careful. It may be dangerous. We know how to revert changes from our local commit. When we change something, added it to index and then made a commit. But in this video we will cover the last part from reverting changes. It's how we can revert changes from remote repository. So let's imagine we committed it and pushed something to the server, and we want to revert it and undo these changes. So let's create our changes. Again, let's edit our sunk.txt. So we can add a new line, and we will add something like a comment what we need to revert. Let's save it. Let's check. Yes, it's modified. Let's git add, git commit. Git status, so everything is okay, and now we can push to server. Let's git push. So we have rejected because there are some changes on server, so let's call git pull, get the latest data from the server. Okay, we need to resolve conflict, but right now we don't have the time for it. Let's just reset our changes. Let's go 3 commits back, git status, and let's git checkout, git status, so we will check, and right now let's try to git pull the latest data. So now we have the updated version from the server, and right now let's clear it, and again let's modify our file. So let's call monosong.txt, and we will add something what we want to revert. Save it, git add everything, git commit, git status, everything is okay, and let's git push. So we see everything was pushed, and to check it and be sure, let's open our file, our GitHub repository, let's open it, and we see that song.txt was updated 27 seconds ago. Let's go. So we see this change, and also we can see commit, what was added, we can see parent, what was before, and right now we want to revert it. So how can we do it? Let's go again and define this commit. So it was made in this commit, so we need this SHA-1 token. We can copy it here, or git log pretty one line, and it's the same token is here. So let's call git revert and this commit, or we can type just first 5 letters, it's okay. So, and now what's going on? Git opened text editor V, and it's really a very old editor. It was in Unix, then in Linux, and then in Git, and here we can edit our commit message, and what we're going to do. So here mentions that we revert new commit, and this reverse commit, and this is SHA-1 token of this commit, and what everything else is commented text, and it won't be in your commit. So you can edit here. Let's add something. So it's V editor, and to start editing you should click insert button on your keyboard. In case if you have a MacBook or you have this keyboard, you can press I keyboard, and then here in the bottom, in the left corner, you will see that insert. It's insert mode, and now we can edit something. And let's type we revert this commit, and now we can stop editing. So to stop editing, you need to press escape button. Here you can see that we have now this mode, and after that you need to press colon. Here in the bottom you can see, and 2 letters, it's WQ. W it's write, and Q it's quit, and Q is quit. And let's press enter. So now we left this editor. Let's check git status, nothing, git log, and we see here on the top we have a commit, revert new commit, and it reverts this commit. So how it works? It just creating a mirror commit and revert everything what you do in another way. So it adds everything what you deleted and deletes everything what you added. So let's push it. So let's call git push. So now it's pushed, and let's go back. open our sound.txt. So we see that we have no such changes. We have last commit, and in this last commit we see that this line was deleted. And let's go to the parent, and in parent it was added. So this commit just deleted everything what you did in your commit. What's the benefit? That you have history of all your changes, so you know when was something deleted and was something reverted. What is disadvantage of this approach is the same. You have the history of all your changes. So in case you push some passwords or PIN codes or some security private information, it will be saved in history. We can revert it, but we'll talk about in the end of this course. So the next one, what is very interesting about this feature, that Git reverting, it's a commit, and you can reverse commit. So let's clear it, and again let's open our last commit. So it's this one, and we can revert this commit again. So let's call git revert, and first 5 letters, it's even not 3, not enough, 5, 2. Okay, and we are again in V. So right now we do not want to add any text. We can just press escape and colon Q, and if you do not want to write something, just leave this editor. You can press Q and exclamation mark, and that's it. Let's check git log pretty one line. So right now we see that we have new commit. It's our local head here, and we can see that origin master and origin head are still here because we didn't push our changes. So let's again git push. We'll push our changes to this our remote server. Let's check it. So, and again we see these lines. Everything was reverted again. So let's go to this commit. We see that it was added. One parent, it was deleted. So if we will take a look on these commits, we can see that reverting, new commit, and everything works fine. So do not afraid revert your changes, because always you can revert your reverts, and everything will be saved and works fine. Thank you for watching. Let's talk today about gitignore. What is it? How can we use this feature of Git? So not always you need to save everything in Git. Sometimes you have some logs or build results or even some unit test code coverage files, and we do not need to save it to Git, because all this data, they are generated during work and we do not save it. So how can we prevent adding it to Git and do not push it to repository? So for this we have a gitignore file. It's just simple file. You can create it with a dot. First character is a dot because it should be hidden, and when you created all file names or templates of these names you will put in this file, they will be hidden from Git and they won't be added. So how can we add these files? So there is some mask or template of files. For example, when we create with asterisk.log, it means that all files with the names, with any name, any file with any name with extension log will be excluded from Git. At the same time, if we want to add something of it, we can use it with we can use this template to prevent removing from Git. Also, we can delete. We can remove from Git the whole folder or subfolder. So let's try to do it. So in our Git we have two files and the Git status. Everything is okay. So let's create this file. And let's create some log file just to test. Log. So we have these files. Gitignore is hidden, so we can see it here. So if we call git status, we will see that we have two new files. It's a gitignore and a logignore. And if we will open our Git GUI, rescan, we see that we have two of these files and both of them are empty. So how can we hide this log file? So let's edit gitignore, and here we will add just a log file. Let's save it, and now git status. So right now we see that we have just gitignore file. Let's open GUI again, let's rescan, and we have again gitignore with this file. So in case we will add a new file, touch file log status. So we see that we have this file again because it's a log, but it's with another name. Let's edit our gitignore, and we'll change with this pattern. So every file with extension log will be hidden. So let's save it, and again git status. So we see that we have just one gitignore. After that you need to commit gitignore and push it to your repository, and every developer in your team will use these rules and all files will be ignored. So as I mentioned, we use it on everyday work. For example, if in case you are working with WebStorm, as I'm working, first of all what you need to add the idea folder, because everything what is related to WebStorm configuration, it saves in idea folder. So you will add this and remove. In case you're working with JavaScript and Node.js, you can add node modules, and all your node modules will be excluded. If you're using other language, for example Python, there are a lot of libraries. You don't need to push these libraries to repository, you can ignore it and then just download when you install your project. We will talk about branches in Git. So what is a branch? Previously I mentioned that in Git everything is built using graphs. In graphs we have nodes and the links between these nodes. So our Git structure looks the same. We have a lot of nodes, it's our commits, and we have links to these commits. So we have, for example, commit B, and it was created based on the commit A. So to understand how it works, let's take a look on Git. Let's open our Git key, and we will see it there. So Git key. And so here in Git key we have all our commits, and they look like nodes. And here we have a parent, it's a link to parent commit. We can go by parent, and here you will see that we are moving in the beginning of our list, and in the end we will get our initial commit with no parents, just child. Usually it looks like a line with your commits, and the next commit is based on the previous one, as I already mentioned. Based on this, we can take a look on our application and split this application into the features. So our application, it looks like a bunch of features, and each feature has some functionality. Also, you can imagine that it's like a tree. In tree we have a tree trunk, and from a trunk we can create branches. Each branch is some feature. In our case, from commit B, we created new piece of functionality. It's a feature, small feature F. It's a new branch, and then we created from the C commit, we created a new large feature with a couple commits. It's this one new large feature, and these parts, they are branches. So after that, when we finish some functionality or branch, we can merge this branch back into the tree, into the trunk, and it calls merge. In this case, we can see the whole life cycle of a feature, how it was implemented and how it works. So in Git, we can describe two types of merging branches into the main master. The main branch, it calls master, and when we merge something into master, we can describe it as two types, is a fast forward merge and non-fast forward merge. So let's start from this one. In our case, we have a head, it's a pointer which ways our last commit. So when we had the B, pointer was on B, it was a head, then we created commit C, and now pointer is on the C commit, and it's a master. Head shows that this is a master. After that, we created a branch with 3 new commits. It's some feature, and in this branch we have its own head, and this head it shows to feature. And when we are going to use fast forward merge, we can just simplify our work and just move head from master, move it to feature. So, and it will look like this one. So we just moved our head, and now the last commit is F, and everything what will be next, it will be continue from the F commit. So how can we do it? Let's go to our code, but first of all, let's take a look on Git. Let's close it and cd Git, and here we have head. Let's so in head we have ref that it shows to head master. What? Right now, let's create a new branch, and to create branch, we need call command git checkout and put branch name. So git checkout, and so we haven't any branches. To create a new branch and checkout in this branch, we will call it with parameter b and a name of branch. It will be feature. So right now we are in switch to new branch feature, and in case we will go to git and head, we will see that now reference to head is this head's feature. So right now we switched our commit. So let's go back and we will edit some file. So let's log, not log, for example, song. We will edit our song, and here we can remove this one, and we will call it this one. Also we will git edit and git commit. After that we will double this operation. So let's again song, edit this song and add the second commit, save it. Again, if we call git status, it's modified. Let's call git add and git commit, but it will be second. So git status, okay. Let's take a look in git log, and here in the top we can see that it's a second commit, and here we have SHA1 token. It shows that head shows to feature, and its token is 432. Let's switch again to master. Now we switch to master and call git log, and here we see that the last commit, it's absolutely another one, and the head shows to master. So how can we merge our feature into the main master branch? To implement it, we need to go with the main feature, the main branch, the branch what should be the destination branch. So we need to merge branch to master. So right now we are in master, and now we need to call command git merge and pass the name of branch we want to merge into this branch. So let's call git merge and feature. Feature, it's the name of our branch. So let's call it. And here we will see that it's fast forward, and we merge to song.txt. And let's call git log. So Now we can see that head is a master, also is a feature because it's the same branch, and it's this commit 432. And now master is updated and points to the same, head points to the same commit. Okay, so what is non-fast forward merge? Non-fast forward merge, it's similar, but it happens when we have something new in our master branch. So for example, from a C commit, we created the same big feature in a new branch, but in master something was updated and we created new commit. And in this case, we can't just move pointer to this one feature because we can lose some important information in another commit. So to fix this problem, we can create a new commit, and this commit, it will contain all changes from this branch and also changes from our new commit in the master branch. And then we will create new commit and push everything to this one. So let's try to do it. So let's clear. To implement this functionality right now, we are in master. Let's check out the feature, and we will create a couple of commits here. Let's add it again. Let's save it. Let's add, and we'll call commit in feature, and we can do it again. So let's repeat this operation. And save it. So after that, we can git log. We will see that the last commit is B0C0. Let's clear and let's go to master branch. So in master branch, we will add the same file. So, or you can add another file. Let's add readme. Just add some information, save it, and git add. So we updated readme, and right now we want to merge our feature branch into master. So how can we do it? The same. The destination branch is a master, and the source branch is our feature. So let's call git merge feature. And here what we see is our famous V text editor, and here we need to create new commit with a text. In our case, default text is merge branch feature. We are not going to edit anything, we will leave it. So we click escape, colon, write Q, and press. After that, we see that merge made by recursive, and it's not fast forward merging. Let's check git status. Nothing, and git log. And in git log we see this new commit 1bbc and message merge branch feature. So we merged all changes into master, and now we have the final version of code in our master branch. And now we can open git to see how it looks in the end. So let's call git. And here we can see that we have such graph. We have second commit. After that, it was created branch, and in the end we have a feature, and everything was merged into the master. So in case we will create a new commit here, And now we see that we have all commits. Git add and git commit. Let's open git key again, and now we see that final version is master, and we again go one by one in one line all our commits. All branches were behind, and now we have the final version of our source code. We know how to merge different branches into one main branch. In our case, it's master branch, and previously it was successfully without conflict, but sometimes it happens that we have some conflicts. So to find out how to resolve these conflicts, first of all we need to learn what is a conflict. So what's conflict? Sometimes different developers editing, modifying the same file in different branches, and then when we try to merge it into one file, into one branch, we have a conflict because Git doesn't know how to solve the difference in two files. For Git, it doesn't matter what you edit there, but it just knows that the same file in the same place, there is some difference, and somebody should solve and decide which part, which commit should be chosen. So let's simulate this case. Let's go to our Git, and we will create two commits into different branches, and then we will try to resolve the conflict. So we are in master, so let's edit our song.txt file, and we will add some so we save it, we will add to Git and the commit. So we committed it, and now we see that there is nothing. Then we can git checkout. So we switch to feature, and now we will edit the same file in the same place. So here we see that the same changes. Let's add changes from feature. Let's save it. Let's add git add and the git commit. And now we go to git checkout master. Now we are in master, and now we are in destination branch, and we need to merge our feature branch. So let's call git merge feature. So here we can see that after merging and the content merge conflict in song.txt. So automatic merge failed. Git couldn't merge these changes automatically, and we needed to resolve this problem by ourselves. So somebody should find out what version should be chosen and decide how to do it. So let's check git status and git log. We see that here both files are modified, and in git log we will see that almost nothing interesting. Okay, so how can we resolve this file? Let's open this file. It's song.txt, and here what we see. In the beginning we have the previous version, what was both in two files, so it's the same, and then we have these symbols and the head. Head, it means that this current branch, in our case it's master, and all these symbols, they are non-compilable in any language, so doesn't matter what language are you using, your Git or your IDE will know that it's some special strange characters, and it should be solved somehow. So here we have part from first feature branch, and here is from master, and these changes are from feature branch. So we need to edit it. We can edit it by manually, and we will decide which part should be added. So let's edit it. Feature branch, we do not need it. So we decided that this version of the file should be the final, and we are happy with it. So let's save it. And now what do we need to do? Let's check status again. So they are both modified. We need create commit, just usual commit, and save this data. So let's again git add this file and git commit. Final version. So let's save it and check its status. So we see that everything is modified and everything is successfully pushed, is successfully committed, and git log, we see that this commit is the last one. This commit is the last one, and the file was changed. To be sure how it works, let's open git k and see how it looks from visual perspective. From visual perspective, we see this branch, final branch. Here we will see some txt, and we see the last changes was added both in two commits. So right now we know how to resolve such conflicts. Let's find out how we can avoid conflicts, because resolving conflicts is not a good idea. You should try to avoid it, because right now it was just one file. It was very simple. We could edit it in some text editor, but sometimes there might be a lot of files, hundreds or thousands of files, or it might be some difficult files, for example Microsoft Word documents, and it's very difficult to resolve such conflicts. To avoid such problem, we need to create short commits. So do not create one big commit with a huge feature. Just commit as often as you can, and then it will be much easier to resolve conflict in case it will happen. The second part is no edits white spaces. It's all non-printable characters. For example, new lines, tabs, or spaces. Try to avoid it, because the file is the same from logical perspective and from the content is the same, but when you add some space or new empty line, Git thinks that it's a new version and there might be conflict. And also merge often. So as often as possible. Usually in our development work, every morning we came to work, we try to pull latest data from the server, merge to our branch, and if it's possible, merge a few times during a day, because sometimes your problem can be solved or fixed in another branch by another developer, or if you change some common files, there might be some conflicts and you need to resolve it as soon as possible without minimum effort. And also what other we can use, it's solving conflicts. It's first of all, you can decide abort, do not resolve conflict. For example, it's evening and you have no time for resolving conflict because you need to choose what version will be committed. You can just abort and resolve this conflict on the next day. Also, sometimes you can choose just somebody's version. For example, if you merge another branch and you know that in this branch everything was fixed, you can just decide check out with X theirs, and your changes will be removed, and or you can use just your version and everything else will be deleted. So also you can resolve it manually by div, git div. It's not so easy how it is with opening file and editing by yourself. And also you can revert changes with git revert. Also there is some merge tools which helps you to do it. Usually I resolve conflicts in my IDE. It's WebStorm, where Git is integrated, and resolving conflicts is very easy in this tool. And that's it how you can resolve conflicts. Thank you for watching. We already know how we can merge our feature branch into master branch and finalize our solution. But sometimes it happens when we have a branch, we created new feature branch from master, it's from C commit, and we don't want to merge it right now, but we want to get the updated data, new data. So for example, let's imagine that someone created a couple of commits with very important features or bug fixes, and you need these bug fixes in your branch. So, and yet you are not ready to merge your branch to master because it's not finished, but you need these changes. So how can you do it? And you do not want to merge master into your branch. So here you can use rebase. How rebase works? In our case, we see that commit 1, it was created from commit C. So C1, it's a child of C. C is a parent, we can say basement of this commit. Using rebase, we can just move this pointer from C to E. Let's do it. So we just create a small change in history for this local feature branch. We changed the parent of this branch. So right now this branch is created from E commit. So it means that you have all data from master branch, and now your branch is your feature branch works, and it has a new parent branch, and it works fine if you do not change the history of main master branch. So what is the golden rule of rebase? So never change history in your public branches in master branch in our case. So for example, we have master branch, and we rebased from master, and then we rebased from feature branch, and it means that we pushed our feature branch inside the other history. How it can look in real life? For example, every day we deliver some tasks. It's Monday, Tuesday, Wednesday, Thursday and Friday. And on Wednesday we decided to create a feature branch. It's Friday, for example. We implement some functionality, and then we pushed to history, and we changed public history, and now it looks like Monday, Tuesday, Wednesday, Friday. We pushed the changes which we made on Friday, and then it's again Thursday, Friday. So it's not a good idea. So try never rebase master or any other public branches which is used by another developer. So it works great for your local feature branches. We will talk about one small command in Git. It's cherry pick. So what is cherry pick? So let's imagine situations that you have created your feature branch from C commit, and after that in master there is development, and somebody already created a couple of additional commits in master branch. And in one of these commits there is some very important bug fix. In your branch you want this commit with fixing this bug, but in the same case you do not want the whole commits, all other commits, E or anything what was added additionally. That's why you can't rebase, and you are not ready to merge your commit because you didn't finish your work. You didn't finish your work, and you just need this commit D. So how can we do it? How can we get this commit? Really, we need just copy this commit to our feature branch and use it during our branch. So copying this commit, it calls cherry pick operation. Really, I didn't use it very often in development experience, but just a couple of times I use it. So how it will work, how it looks. So we just copy this D commit and add it to our feature branch, and then this commit, it has its own SHA1 ID, commit ID is the same as here, and then when you will decide to merge your branch into master, the Git will know that it's the same commit, and it will skip any conflicts, or you won't resolve conflicts in this commit. So in case you need to copy some commit, some implementation or some fix, you can use this cherry pick operation. It's pretty simple and it might be very useful for you. Git tags. How can we use it? How can we create it? And why do we need such functionality? So Git tag is just a highlighter. We can say it highlighter. It's a text marker which shows some, which can highlight some commit. It doesn't create another commits, it's just additional marker. We can create it with the git tag and version name and the tag name command, and we can push it to the server. So how can we use it and why do we need it? For example, you're developing a software and you finish some period and you have final version on this date. For example, you finished sprint and you have production ready version. So you don't want to mark it as a commit because commit has a SHA-1 name and it's difficult to find out what was the last one, and it's difficult to distinguish between other commits. So you can mark it with some name, proper stable name, for example version 1, version 2, and then you can use it for deploying your software to production. Let's create tag. So let's check git status. Everything is committed, and let's create tag from this commit. So we can git tag and pass a name. It will be version 1, I will call it. So we created this tag. It's called git status. So nothing was changed, and if we call command git tag list, we will see that we have one tag, and let's call git status git log, and now we see that we have our last commit, it's a head, and also we had the tag version 1, and now we can push this tag to the server. Let's clear it, and let's call git push. Right now we will push all changes we had before, all commits, and let's check it. And let's check our git. So what do we have here? So in git we have all our commits, and let's check here. In commits we have additional tab with tags. Right now we have no tags, so let's push our tags. So we need git push tags. Let's call this command, and now we see that we pushed one tag, v1. Let's refresh it. And here we have this tag v1. What does it mean also? Let's create some new commit. Add something, doesn't matter what. Save it. So now we see that head is on the last commit, but here we have this tag 1. Using tag 1 we can use it for checkout. For example, you need to check out some commit and you don't remember SHA-1 code. It's difficult to remember it, but you know the version name. So you can call git checkout v1. So here we see that switching to v1. So we switch to this branch. If we want to undo, we can git switch and minus to get back. So right now we can get log, and we will see that head is on v1 version, so we got one step behind, and now origin and master are in the same branch. So we can check out by SHA-1 by commit number, or we can check out by tag name. So this operation might be very useful if you want to mark some stable version of your code and then use it for deploying to production. Git stash. What is it? So let's imagine a situation that you have a feature what you should implement, and you created a branch for this feature. You already implemented 2 commits, and then you have something not finished. Usually it calls work in progress. So you have unfinished work, and you need there is a new task and something immediately you have to fix in master branch. So you need to switch to master branch and finish this task. So how can you leave this unfinished work in progress? You have two options. Right now you have two options. It's merge to master, but it's not ready yet, and you don't want to merge it because it's not finished. And also you can check out and delete these changes, but it also is not a great solution because you already did a lot of work and you don't want to lose it. So how we can do it? We can save this data to some temporary storage. In Git stash, it's this temporary storage. It's not a commit, it's not a tag, it's just storage where you can leave your temporarily leave your changes and then go back and finish this data. So to use this, we can call command git stash save and add some description. Also, we can get a list of such changes. So let's try to simulate such situation. So we have our Git and let's edit some file. Let's edit this file and let's delete something. It doesn't matter because we need just changes. Let's save it, and also let's create some new file. Let's add some file. Let's check status. So right now we have modified some txt and added git text. So right now we can add this data to stash. So let's call git stash save and some description. Not changed or finished work. So now we can see that the saved working directory, it was saved on master branch. So let's call git status, and what do we see? We don't see modified song.txt because Git knows about this file and it moves to stash, but Git doesn't know anything about the new file.txt. That's why this file wasn't moved to stash. But untracked files, it's not a problem for us if we want to check out for some branch. So let's git checkout feature and call git status. So we are in this file because, as I mentioned, it's untracked and it doesn't matter for Git, and we are in new file. So here we can call git stash list, and we see that we have one name. It's not the best naming, but we see that on master we have one stash. Also we can create some stash in this branch. So let's first of all let's check song.txt, and we see that we have all lines we added before. Let's edit it again. It's what we had in this branch. Let's save it, and again let's call git status, this modified, and git stash save, git stash list. So right now you see that we have two files in stash. Let's switch back to master. So again we have this untracked file, git stash list. We have two options, and if you see git song, what do we have? Change from feature. So it's our solution. And now we have a few options how we can get this data. We can call git stash pop. it will remove data from stash, and we have git stash apply. It will return all changes to work in progress, but data will be saved in stash. So let's try the second one. We will call git stash apply, and we need pass name of this stash, and it's stash 0. So now we see that we have modified song.txt. Check content, and here we see, and now we see changes from feature branch, because we reverted changes from 0, this one, from 0 stash, and 0 stash it was on feature branch. So in case we want, in case we wanted changes from master branch, we needed revert changes from stash 1. And also, if there are a lot of stashes in your storage, you can drop the stash and delete it completely. So it's a simple way how you can use this temporary storage and save your data while your work is in progress and you do not want to merge it or commit. We'll take a look on the concept of remotes. What is remote repository? So when we work with Git, usually we work with two repositories. It's your local repository and origin repository. It's some server where is saved your repository copy. Right now we are using Git on GitHub, but you can use it the same way Bitbucket or GitLab. It's almost the same. So we have a Git local master, and we can push data to origin server or remote server, and we can use Git fetch to get data from this server. Also, it's the same for features. When we have some feature branch, we can save this data in our local feature branch and push to origin feature branch and get fetch data from the same origin feature branch. So to add or remove remote, we can use git remote, or if we want to view, check what we have, we can use git remote. So let's check how it works in our repository. So let's open our repository and call git remote v. So here we see that we have a repository for fetch and for push. It's the same repository, it's Git on GitHub, and it's okay. It's one of the best configuration you can have, because everything is saved in one repository and you push and get data from this repository. It's how it should works. So how we can do it? Can we use this remote feature? So let's imagine here we have our repository, it's Git basic, and let's imagine that you have lost access to this repository. Maybe you was a part of a team and somebody deleted you from this repository, or it wasn't your repository, but what's important that you have the whole history of all commits on your local repository, and you want on it your own new repository. So let's create new repository. Git demo 2. It's public without readme. Just let's create it. After that, here we see that we have SSH. We have this SSH repository, and let's go to our repository and let's delete this one. We call git remote remove origin, and let's check again. So now you see that we haven't remote repository, and now we need to add this repository to new repository on your server. To do it, let's call git remote add origin. It's the name of our server and URL. Don't cherry pick this one. Copy. So let's push. Call it and git status. We have the same modified files. It was from the previous video. Git remote verbose, and we have right now we see that links was git basic. Right now it's git demo 2. It's another one. So and now we can push all our data with all the history to Git repository. First of all, let's add changes what we have. Commit something like it. Git status, everything is okay, and now we can git push. So we see that Git shows that upstream isn't configured. Let's call this command, and it's for feature branch. We have feature, but in case it will be in master, here will be a master branch. Let's call it. We see that it was pushed feature to feature, and now we have empty repository. Let's open it, reload, and so now we see that we have feature branch and we have 15 commits. So the whole history was moved to new repository. And in case we need checkout master, git push. So we see that upstream for git push isn't configured. For master, let's copy, set it, and git push. Now we pushed everything from master to the server, and again, let's open it. We have 15 commits. Let's switch to master, and we see that in master we have 20 commits. It's expected behavior, and also let's clear it, and let's call git remote show origin. What do we have? And this command shows this information about this remote repository, and you can see that fetch and push are for this URL, head, branches, and everything is okay. So now in this, so let's sum it up. We know how to create a Git remote repository. We know how to push all your history, all your repository, local repository to the server. We can add or delete this repository, and we know how to get this data about this repository. We will talk about branching strategies for Git and why do we need them. So branch strategies, it's an approach how do you organize your Git branches in your project. It's a very important step on project beginning. Usually when we start a project, we decide how we are going to organize our Git, and then based on this strategy we can organize our work. So in this video we will take a look on a couple of these strategies, the most popular. So the first one is centralized strategy. Centralized strategy, it's a very simple strategy when you have just one branch, it's master branch, and all your commits are created during this branch. So for example, we have two developers, Maxim and Oksana, and they creating commits, and these commits are in one master branch. So when can we use this strategy? For example, we can use this strategy when no one knows what is Git and how to work with it. They are new in Git and doesn't know how to work with Git and with branches, so it's okay to use one branch. Also, it's possible if these developers previously used another branch, another version control system, and they do not know about branching concept. Also, it might be used if you are on some hackathon and you have no time to create different branches and you need just push faster everything, and you can use one branch. Also, sometimes I use this strategy when I'm creating something for myself and I'm the one developer, only one developer, and there is no reason to create different branches. I can create commits and save these commits in one branch. So this strategy can work. For a big project, it will be a problem in case you will have more than one developer. So for this case, we can take a look on another strategy. It's a very popular strategy and we use it very often, and already in the previous video we discussed this strategy. It calls feature branch workflow. How does it look? So we have the same master branch, the main branch, and for each other feature we create small branch. So for example, we have implemented some new functionality and we created a branch for this small feature, and after that, when this branch will be finished, we will merge this branch into the upstream branch. In our case, it's master. It's a source branch, and then we have another large feature. We can create another commit. We can create another branch with a lot of different commits, and when these commits will be finished, we will merge this branch into the master. It's a really popular branch, and during my experience, we use it very often. If you have different developers, and each developer should develop their own branch, their own functionality, fix some bugs. So in this case, it's a good solution for using different branches. Another very popular strategy is Git flow. It was created in 2010. It's 10 years ago. And what does it mean? During this strategy, we have a master branch, and in this master branch, we save just production ready code with the tags. Tags we already discussed in the previous videos. So in master we have code which is published for production, and we do not use it during development. For development we have another branch. It's called develop or dev branch, and all commits, all branches will be merged to this develop merge. During development we can create feature branches. It's like the feature branch strategy. We create different branches for different features. When we finish this feature, we will merge this task into the branch. It is develop branch. When your work is finished and the solution is implemented, you will push your code to the master, and it will be production ready code which will be published to production. Also during this approach, there are some additional specific branches, that's release branches and hot fixes. For example, we have some release branch. We can push our code from code freeze to this release branch, maybe fix some small changes, and then this branch will go to production. Also hot fixes, in case developers or QAs have found some bugs. They found bugs and we need to fix it as soon as possible, so we can use the hot fixes branch and push this to branch, and then it will go to production. So it's a very popular strategy. We use it on our projects too a couple of times, and it's very good in case you have average size project and 5-10 developers. It's a good approach. Another one strategy we will take a look is integration manager workflow. So how does it work? During this approach we have different developers. Okay, so the basement of this approach is remote branches. We already discussed remote, and we know that when we work with remote branches we can pull data and push data from different remote servers. So this strategy is based on this approach. So we have different developers, and each developer has his own public developer repository, and when we finish some functionality we push our changes to this repository. And we have integration manager. It's a special person which gets this pull our changes from these repositories and resolves all conflicts and finalize our code. And when code is fine, this manager pushes this code to Blast repository. Blast repository is a special super repository which any developers haven't access to this repository. They can just pull data from this repository, and only integration manager can handle this repository and has rights to push to this repository. So how it works? Developers push their changes to special public repository. Integration manager pulls this data from repository, checks if everything is okay. Usually this manager do not create code, don't write it. When everything is okay, he can push this data to Blast repository. After that, all developers can receive the latest data from this Blast repository. This approach can work very good for distributed teams when they are in different locations and can discuss how to organize work. Really, from my experience, I didn't use such approach, but it can work. Another similar approach to this one is dictator and lieutenant's workflow. It's very similar. The only one difference that we have something like proxy with a few lieutenants which receives data from your developers and then push this data to dictator. And then we have the same blast repository, and only dictator has rights to push data to this repository. This approach works for really huge projects. For example, as I know, Linux kernel is written using this approach because there are a lot of developers. It might be for open source. When you have a lot of developers different and you need to handle somehow this merge request. So every developer, they has their own lieutenant and they pushes their data to this lieutenant. He or she resolves conflicts and pushes data to dictator, and this dictator has the final version of the code and just and he can push to this blast repository, and then developers get updated version from this blast repository. And one more approach, it's forking workflow. It's based for GitHub approach. So how can we do it? It works very well for open source projects also. We have original repository on GitHub, and we have original developer who created such approach, such repository, and it's some popular and important module, and this developer doesn't want to share access to this repository with other developers. In this case, other developers, they can create a fork of this repository. Fork, it's a copy of your repository. They just forked your repository, and they can create a different couple commits with some functionality or bug fixes or some additional solutions, and then they create a pull request. Pull request is something like commit, but in GitHub approach, and they created pull request with all these commits, and this pull request is assigned on this original developer, and then developer can decide is these changes are okay, and if everything is fine, he can pull this data and merge into the original repository. In GitHub it works very easy because there is one button which you can click, and all data from fork repository, this commit, or in our case pull request with a few commits, will be pushed into your repository. From my experience, I used this approach when I worked with GitHub and public repository and contributed to one library which is used for its templates library. And when we needed to create some contribution, we forked repository, created our solution, created pull request, and then when everything was okay, code was reviewed, this pull request was merged to original repository. It was the last branch strategy I want to mention. So based on this, you can decide what strategy you are going to use, and in this case you need to consider size of your team and rights to repository or a project. Do you have rights to push a new repository, or you need to create your own fork and then create pull request to this repository? And this topic is also popular on for interview questions. And if you're going to have some interview for some company, somebody can ask you about different branching strategies and how does it work and how it affects on your project and time of developing your project. I want to summarize our course and give you a few options what you can do the next. So first of all, I would recommend you to read two great books. It's Pro Git and Version Control with Git. So the first one, it's absolutely free, and you can find it on Git site. On Git site you can go to Pro Git, and here you can find this book. You can download it for PDF format or for your electronic book, and here is described a lot of additional information, how it works inside, how to work with GitHub, with different tools. It's a really great tool. It's a really great book. Also, there is another book which you can find on Amazon. It's not free, but anyway, it's very useful, and it will be great if you will read it also. So, and here I added a few additional comments. You can try to use it. In this video I will not show you how it works, but you can copy these commands and try on your project, or you can read about this project in these books or internet. So the first one is Git init. From the beginning in this course I showed how we can clone repository from your repository server. It was GitHub, but sometimes you can just create your Git on your local machine and do not connect it to remote repository. And when you call git init, it just create Git. It will create Git repository on your machine without remote servers. Also, we already used two commands for configure your name, email. And there is one more. It's a core editor. By default, as you remember, Git opens editor V, but it's very old and not the best option. So here you can configure path to your editor and call, for example, Sublime or Notepad++. The next command, git blame, it can show, you can put path to file and it will show who edited this file, who and when. Also, the next one is bisect. It will allow you to apply binary search for your repository. So, for example, if you have back in some commit and this commit was made between a couple of months and a lot of commits, this operation will help you in a few steps to find this commit. The next one is logs. We already used Pretty One Line. It shows a small version of log, and also you can try to run it with graph parameter. It should build the whole Git repository structure with branches on your console. Also, you can create your own alias commands. For example, here you can create new command. It calls last, and then when you call git last, it will show you one last commit from your repository. Also, it can show you a log between two branches, difference with master and your experiment or feature branch. It's a feature name. The next one is very dangerous command. It's filter branch, and it allows you to apply some command to this tree. For example, we can remove password.txt file from all files in your tree. Let's imagine that you created a merge request and there is file with password or some security information, and it should be deleted. So this command can remove this information from the history, and nobody will find this information. But what you need to be careful, it's a really dangerous command, so I would recommend you to create a copy of your repository and run this command there, and if everything will be okay, you can run it on your own, because as I mentioned, it deletes history from your repository. The next one, it's a very interesting command, revert. It means reuse recorded resolution. So in Git you can specify some patterns of your code, how it should be resolved, and Git will, when it will find these patterns, it can resolve conflicts automatically. And the last one, it's a submodule. It allows you to create Git repositories inside your Git repository. Yes, it's possible, and you can try it after this course. So, and that's it from my side, and I would recommend you to try these commands and do not stop learning and learn something new in the next courses. See you. Thank you for watching.